The road you walked on this morning probably noticed you. Cities have always collected data. Traffic counts, water usage, power demand. What changed is that sensors got cheap enough to embed almost everywhere, and networks got fast enough to send all that data somewhere useful in real time. The most common sensors you'll find in a smart city are buried in or mounted near roads. Inductive loop detectors, basically wire coils under the pavement, sense when a vehicle passes over them by detecting a change in their magnetic field. They've been around since the 1960s, but now they feed data into software that watches the whole city at once. That data tells traffic management centers how many vehicles are moving through an intersection per minute, how fast they're going, and whether a queue is building up. The system can then adjust traffic light timing automatically, giving a green light a few extra seconds here, cutting it short there, to keep traffic flowing instead of stacking up. Cameras add another layer. Computer vision software can count pedestrians, classify vehicles by type, and spot when something unusual is blocking a lane. The camera itself doesn't store video of individuals in most deployments. It processes the image locally and sends out a count or a category, not a face. Streetlights are doing more than lighting the road. Many newer smart streetlights carry sensors that measure air quality, things like nitrogen dioxide and particulate matter, as well as noise levels and sometimes rainfall. Because there are thousands of them spread across a city, they create a detailed map of where pollution spikes and when. That air quality data can tell a city whether a particular neighborhood is consistently exposed to worse air than others, which helps planners decide where to add green space, reroute heavy trucks, or flag a building whose heating system is out of spec. Underground, sensors monitor water pipes for pressure drops that signal a leak before it becomes a sinkhole. Electricity grids use smart meters to see demand shifting in near real time, so operators can balance load without waiting for a blackout to tell them something went wrong. All of this data flows into dashboards that city operators watch like a pilot watches instruments. A spike in noise complaints in one district, a pressure drop in a water main, an intersection where pedestrian counts suddenly drop. Each of those is a signal that something might need attention. The obvious question is privacy. Any sensor network that can count people can, in theory, track them. Different cities handle this very differently. Some publish exactly what data is collected and how long it's kept. Others don't. That gap in transparency is one of the real ongoing debates around smart city infrastructure. The technology itself is fairly well understood at this point. What's still being worked out is the governance: who owns the data, who can access it, and what rules apply when a sensor network built to manage traffic could also be used for something else entirely. So the next time you stop at a traffic light that seems to know you're there, it probably does. Whether that's a useful piece of infrastructure or something worth watching closely, or both, is a question worth asking out loud. If you want to go deeper, look up your own city's open data portal. A lot of this sensor data is actually public, and it's surprisingly readable once you know what you're looking at.